Okay, so we left off on Monday, and let me just kind of restart our kernel here. We'll restart and clear everything. I'll just check it's running. Why did this not do it? Kernel, okay, here we are. Okay, so we left off on Monday. We imported our NYC flights database, and we did some cleanup of it. And then as I was working, I was just trying to find some stuff. I noticed things weren't quite right, and when we cleaned it up, it's always important to after you do your data cleaning to go through and check and make sure things are correct. And so this is basically the code that we ran last time on Monday. I just kind of put it all together. We turned things into objects, and then we took the last two characters and the first two characters to get the hour and the minutes, and then we converted the date time. The departure times and arrival time columns, the scheduled ones also, and we turned them into date time objects by joining together the year, the month, the day, the hour, and the minute. Okay, and so here are some exercises, and this is how I discovered that there was a problem. Okay, so here I just said, okay, let's find all the flights where the arrival delay is over 120 minutes. Okay, so we just take this arrival delay column, which it shows 120 minutes, or greater than 120, and if I ask for the shape to kind of see its dimensions, we've got about 10,000 of these rows. So these are, there were 10,000 flights originating in New York that arrived over 2 hours late. Okay, and then I just thought, okay, can I do the same using the arrival column versus the scheduled arrival column? Okay, and this, maybe some stuff is lost here, but if you do arrival time versus scheduled arrival time, indeed you will get this is known as a time delta. Okay, it's just a difference between times, and so there's a difference between of 11 minutes. Let me just do like flight's head. Okay, and so its arrival time was 8:30, and its scheduled arrival time was 8:19. So that indeed is a difference of 11 minutes. Over here in row 3, row index 3, its arrival time was 10:04, and its scheduled arrival time was 10:22. So it got there 18 minutes early. It doesn't write it writes it a little bit funny, -1 days plus 23 hours and 42 minutes. Okay, which is the equivalent of -18 minutes, but it appears this way. We do run, and then you can say, is that greater? If you want to just say, like, is this difference greater than 120 minutes? It's gonna give you an error here. It's gonna say it can't compare a time delta with an integer. Okay, and so you have to create another time delta object. Okay, so this is and this is, all of this is via Google. I'm just like, why is this not working? Because it says time delta. So basically, one of the important things is how to Google your errors, right? And so so basically, just you go to the bottom and it says a type error, and it basically means something, the comparison I'm doing between this type and this type doesn't work. So I just basically Googled time delta, and then it says, okay, this is what you need to do. So must use a time delta for comparisons between time amounts. Okay, and so to do this, I say I want a time delta of 120, and then you specify the unit, in this case minutes. So you do pandas dot time delta 120 120 minutes, and then now we have a true false Boolean vector, and I can feed that into flights dot location to basically filter down the rows that have this as true, and then I ask for the shape. Okay, and then when I did this is when I discovered my serious error or serious flaw, in that this number is 7,400 versus this number, which is 10,000. Okay, so there's like a difference of like 2,600-ish. Okay, so that's, if that happens, you should stop and say, okay, I got to figure out what's going on, right? So basically, so one of the things I did next was I said, okay, well, let's see what rows appear when I do it this method and what rows appear when I do this method. Okay, so here I basically just say, let's take the this method where we're saying just arrival day greater than 120, arrival delay greater than 120. Let's pull out the index here, and over here I've got basically where the arrival time and the scheduled arrival time has a difference greater than 120, because that's what I'm thinking it should be, and I ask for the index there. And then you can ask what's the difference between these indexes, and it tells us. Okay, so it says let's look at this case here. So I'm going to say, all right, let's go to flights location 151. Okay, all right, and when you look at it, this requires some detective work and thinking, right? So it said the scheduled departure time was 18:35, 6:30 in the evening, and the departure time was 8:48. Okay, 8:48 in the morning, and the departure delay was 853 minutes. So that's like 14 hours. Okay, there was a 14-hour delay. So basically, what happened is that it was scheduled to leave 6:30 in the evening, and then it didn't leave until 14 hours later at 8 in the morning the following day. Okay, and we didn't account for this when we did our cleanup. When we did our cleanup, we just said take the date, chop it up, and append that. And so when we look at the arrival date and the departure date and the scheduled, so the scheduled departure date was January 1st, 2013, 6:35 in the evening. And then the departure date was January 1st, 8:48 in the evening. Okay, but what it actually is that this departure date should be January 2nd, 8:48 in the evening. Okay, and so that's a problem that we encountered. Okay, and then and I was just kind of going through a bunch of these things, and then there was another issue where I saw, I didn't write the code, but basically I found some issues where we had things that were not a time. Okay, we had basically missing time values, and when I looked at it to figure out why we're missing times here, we can see here the departure time was 10. Okay, the scheduled departure time was like 9:35 in the evening. There was a 2.5 hour delay, okay, which took us to about basically midnight, 12:10 in the morning, and so 12:10 would get written as 00:10, but in our thing, I guess the CSV doesn't have leading zeros, and so it dropped those and it just went in as 10. And then when we were using our thing to extract the minute and the hour, it ran into a problem. It got 10 as the minute, but then it had an empty string. It didn't pull in zeros. It had an empty string for the hour. Yeah.
Just a question below on the NAT.
Yeah.
What's the difference between that and NAN?
So yeah, NAN would be not a number. Because these are coded as time objects, it's going to say not a time.
So it could still have a value there? In a datetime object?
No, I think it just means missing. It means missing, but because it's a time value, it's a missing time value. But yeah, we don't. I didn't realize it used NATs until this. I don't know if there's other NA something things, right? Because when it's like a missing string, you get NANs, and missing. We don't have the ability to have missing integers in Python. They get cast into floats, and you have missing numbers. So yeah, but I guess for times it shows up as NATs. So anyway, I decided to just write up some code to kind of clean up these issues. So we need to make sure that if there's a delay that pushes us to the next day, that the departure delay shows up as the departure time shows up after. Okay, and so I don't know if this totally works, but we'll see. Okay. All right, so I kept all of this the same in the beginning, and I just I left some of the things. I reduced this so only a few things are being strings, and then so I created I pulled out the hour by saying pull everything but the last two characters, and then I use np-where. np-where is kind of like a if-else in that you can replace things in an array with values if a condition is true. So here I'm going to say where the hour is equal to nothing or equal to an empty string, put in 0, 0, 0. Otherwise, put in the hour. Okay, and so this will do np-where here. Let me just kind of do a little demo here. So if a is numpy array, and we take, I keep wanting to like mix my R and Python code here. Let's do we'll do A and nothing and C and D. Okay, so this is my numpy array, and we'll go ahead and print out A. And here I can do np.where on A equal to empty string, and we might want to say replace that with 100, otherwise put in the value at A. Okay, and this indeed does what we want. So it replaces the empty string with the thing here. Or I mean, you could let's see. I don't know what else we would do. Okay, so we have that. An issue though is that because we're using NumPy, we lose the index, which is very important when we're doing pandas. So here we have to make sure we preserve the original index that exists. So we're going to feed this back into a series, a pandas series, and then we're going to preserve the index by saying make sure you use the index from the index currently associated with the hour. Okay, and so that updates the hours, and it basically puts in zeros where it had empty strings for issues where we get the 10. And then this is what I did for the departure date and time. For the scheduled departure date and time, we apply the conversion where it goes through this process. And then for the actual departure date and time and the arrival date and time, I'm taking the scheduled time and I'm adding the departure delay in minutes to it. Okay, because that column exists for us. And then this part, I run another numpy where, okay, and this is a little bit harder to read, but I just say if for whatever reason I don't know, maybe this wasn't necessary. Wait, scheduled departure. Okay, maybe I only need to do it here. Okay, but here I just say if the arrival time is somehow smaller than the departure day, okay, if somehow the date assigned to the arrival, like if the arrival time ends up being, you know, back in time compared to the departure date and time, or whatever it might be, then add 24 hours to it, okay? Otherwise, just keep the current arrival date and time and preserve the index. All right, and then we join everything up, and that's what we did. All right, and then so it takes a little bit to run. And we'll take a look at one of our places that we identified. Okay, so location 151, and indeed this looks correct. The scheduled departure time was 6:35 on January 1st, and then the actual departure time is going to be January 2nd at 8:48 in the morning. Okay, which matches what we have here. And then also the arrival date and time is updated as well. So if these, just to kind of preserve the flow of time, that we're not arriving before we departed. Okay, and then also this one, which had the issue with the missing leading zeros, it shows up here, and we can see that the departure date was 10 in the morning. Okay, the scheduled time was 9:35, and then the actual departure was the following day. At midnight, or 12:10 in the morning. Okay, so this, it seems to have cleaned up our issues. I guess it's possible that a flight, I don't know, is that possible that a flight gets delayed more than 24 hours? Or does it just get canceled? I don't know. Okay, I don't know, because we have a bunch of canceled flights, and so I don't know the airport rules. So I guess I could search for if a departure delay is over, 24 times 60, like 1,440 minutes, and then we would have to add like 48 hours or something. I'd probably have to clean up the thing, but I'm just gonna hope that that doesn't exist in our data. But maybe I probably should do a check. So note to self. Oh, shoot. That's not what I wanted. Note to self, maybe we need to check if it is possible for a flight to be delayed over 24 hours. Or maybe they'll just get canceled. Okay. And this is where having knowledge of your data is very useful, right? Like I at least have some cursory familiarity with airports, and that like I've been to one, and so I know flights get canceled and delayed and stuff. But somebody who's has more intimate knowledge of this will be better suited. Okay, so anyway, now that I've done these corrections, indeed, our things seem to work in that we're getting matching values. And that if we look at the arrival delay being greater than 120, and then the difference between arrival and scheduled times being greater than a time delta of 120 minutes, we get matching numbers. Yes?
At what part of the cleaning process did we get that mistake of the arrivals being the same day?
Yeah.
Or like the delay being the same day?
Right.
What part of the process did we lose the information about it being the next day?
So the thing was, is that information did not actually exist in the original data. In the original data, there's only one day. It just says 2013-1-1 departure time, scheduled arrival time, and all of this, okay? That's just the original data. And I thought, oh, you know what? We can enhance this by, rather than just having, because it all started when I said, here's my departure time, and it's written as an integer, and I want it to look like a time, okay? And then when you create time objects in Python, a lot of times it wants to create a date time, like a timestamp, like that includes the date and the time. So I thought, okay, well, that's easy. I'm just going to take this date information and tack it on to the time information. Not realizing or not thinking about the situations where the single date is not adequate when the delay at the airport pushes you into the next day. And so when I created our new date times here, just by saying, let's take this date and tack on the time, it created problems when the date listed says January 1st and you're scheduled to take off at 6:30, but then the delay pushed the actual takeoff time to 8:30 the next day, and then it the way I created it just says we take January 1st and we stick that on, and so now it was wrong, and so these are I guess it's just kind of like a cautionary tale of like sometimes you do things with the best of intentions, but then because you just didn't fully think of every scenario, and it's like impossible to think of every single possible scenario, something goes wrong. Okay, and so it's always good to have a few ways to check for something. Like if this, if I didn't bother checking one way versus the other way, I wouldn't have caught it. Okay, and so sometimes it's good to check it multiple ways to just kind of make sure the results match. But a lot of times these kinds of errors go unnoticed until like way later. You've been doing a whole bunch of analysis and you're like, wait, this part doesn't make sense, and it's only like in the original part you realize stuff. Okay, so anyway, here are just some exercises that come from Hadley Wickham's R book on like some things to practice when you're learning dplyr, and pretty much when you're learning pandas, you want to be able to basically do everything you can do in dplyr. You want to be able to also do in pandas and stuff like that. Okay, so here it says find all the flights that fly to Houston, and so we don't have. There is a filter function, but it operates differently. And so basically, what we use in pandas is .loc, the locator, and then you put your conditions in here. So here we're going to say we want find the locations and flights where flights.destination, and then we run the function is in, and then you can list off the values that you want. Okay. IAH and HOU, I guess those are the two Houston area airports, and we get this. We can ask for the head of this, and well, it cuts it off. But okay, if we want the ones by United, American, or Delta, that's simple. We just change from destination to carrier. And then we can do the carrier codes. For departed in July, August, September, this, what column you use might change your answer. So here I've got departure date and time is in, and then we extract the month out of that date time thing, and we say is 7, 8, or 9, okay? This will give us a different result versus if I look at scheduled, okay? Because scheduled will include flights that were canceled, and And over here, if it's scheduled for September 30th, but then the delay pushes it so it takes off October 1st, it will not appear in this one, but it'll appear in the schedule one. And then vice versa, if it's scheduled for June 30th and the delay causes it to take off July 1st, it'll appear over here, but not in the scheduled one. So it'll depend on what you decide. So these things that seem inconsequential, I don't know, may or may not affect the results of your analysis, right? Okay. More than 2 hours late, but didn't leave late, okay? Here, I use the and sign, the ampersand. So Python allows for, generally when you do Boolean things, you'll use the words and or. But then when you have a vector, or not a vector, a series or a NumPy array of Boolean values, and you want to do element-wise comparison, Boolean logic checks, you use the and sign. Okay, use and for making element-wise Boolean comparisons. Okay, and so this one goes. These are over 2 hours late, but left on time. So I don't know what happened there, but that sucks. So yeah, I was just curious, but then I didn't bother doing like a whole lot of research. But I'm wondering, like, maybe there was like an incident at the airport or something that just said like nobody can land for the next few hours or something, and you have to go in some kind of holding pattern, which is not exciting, but I mean it's interesting in the data, right? And so these are other things, right? They left, this one's delayed by at least an hour, but made up over 30 minutes in the flight. So this is the departure delay is greater than 60. And then, but we're going to say that the arrival delay was less than however much the departure delay minus 30, right? So here the departure delay was 91 minutes, but the arrival delay is only 61. And here, it left basically like 4 hours late, almost 5 hours late, but it only arrived, so it left almost 5 hours late, but it arrived only a little over 4 hours late. But okay, but and then just curious. Somehow, oops. Okay, so there were 29 flights, which is not a lot. There were 29 flights that somehow arrived 2 hours late, even though they left on time. And then there were a lot more flights where they made up that half hour. Okay. And then, I don't know, departed between midnight and 6 a.m. I guess this is only between midnight and 5:59. This is not quite, I'll say, I'm just going to modify the question. 5:59 a.m. All right, so that's what we have here. Okay, so those are just a few questions. And then I was just looking at a few other things, like which day of the week is the busiest. And so we were looking at least as far as the departure days go, we'll pull out the weekday information. 0 is Monday and Sunday is 6. And it looks like Saturday is actually the least busy day at the airport. And then if you want to label these, you can use, so here this produces a series. And then over here, we feed it into a data frame, and then the data frame we rename the index. Okay, rename the index of a dictionary of a data frame with a dictionary, and let's just show the dictionary. Okay, and so here's our, not our dictionary, show our data frame, and we have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. This required this was a little bit tedious to make the dictionary yourself, but that's possible. And then you can plot it, just calling plot on the dictionary. That's for kind equals bar. If you leave kind blank, it'll produce a line plot, okay? And there's a huge dip because the default settings are to just fit the data, whereas when you do a bar, the default settings will start at 0, okay? And you can always adjust the settings there, okay? And then, and just kind of showing there's weekday name, and this pulls the weekday name. By default, though, it sorts it alphabetically, okay? Which is not helpful for us because nobody will ever say Friday, Monday, Saturday, Sunday, Thursday, Tuesday, Wednesday. But that's the alphabetical order. And you could resort it, but then it requires you to kind of manually write out the order that you want it produced. Okay, and then there's the other thing. Instead of weekday name, you can call day name, and you can specify the language that you want. All right, and so now we get, but they also show up in alphabetical order. So we have, you know, what you learned in your high school Spanish class, or, you know, Dienstag and Donnerstag. And then I tried like this, but then I don't know, it didn't produce properly. So I don't even know. I don't, what other, I guess, I don't know what languages are out there, but all right, there's a lot of language. I don't know what languages are supported, but anyway, at least Western European ones are. So okay, here you can create a multi-index. Okay, now we're gonna run out of time again. Multi-index is basically 2 levels of index. So I'm saying create carrier and origin. Okay, so carrier is the different airline company, and then origin will be in New York. In the New York area, there's three airports: JFK, LaGuardia, and Newark. Okay, in New Jersey, but it still counts as a New York area airport. And so I don't know what carrier 9E is, but this creates an index that has two levels to it. Okay, if I ask for the index of this thing, it'll say that it is a multi-index. Okay, and where the levels show this, and the there's, you know, two lists under the levels, and then this shows kind of the arrangement that happens between the 2 levels of index. Okay, and so for example, AS only flies out of Newark. I don't know what AS is, Alaskan or something, I don't know, something. And so index 2 being AS only shows up once here, and then it will, I don't know, I can't, my eyes hurt, but it shows up there. Okay, so the multi-index arranges it this way, and you can create a pivot table where, you know, this is all technically correct. You can imagine, so in if we're dealing in R and we're using tidyr, this is where the values have been gathered. Okay, and you know, pandas or Python doesn't print this, but there's, you know, an implicit 9E and a 9E here. Okay, it's 9E EWR is 1268. 9E JFK is 14,000, and 9E LaGuardia is 2,500. Okay, so those are hidden for simplicity, but they exist. Okay, and so what you can do is you can basically run a spread. Okay, so rather than gather, you can spread the data, which is what we would use in tidyr. In pandas, we use the command unstack. Okay, and unstack will then take these things, the second level of the index, and unstack them. And so 9E has 1268, 1465, 14651, and 2541 spread out there. Okay, and then if there's no values, like for AS, then you get the missings, the nans. Okay, and that's why everything here shows up as a float as well. Okay. All right, there's also, so that's you can do a group by with a multi-index, find your values, and then unstack them. You can also just do it directly using pivot table. Okay, so pivot underscore table takes in your data, and then index, which will basically be the rows. You can specify I want the carrier to be the index, and then I want the columns to be the origin. Okay, and then when you do a pivot table, the default function is to use the mean, but in this case we want just the count. So you specify the aggregation function and you say count. And when you do that, we get the exact same results as up here. As doing a multi-index and unstacking, we can just do pivot table and we get the same things as well. Okay, missing values where things are not there. Okay, and over here I have the exact same thing, the pivot table, just I'm taking this pivot table and then I'm calling plot, and we're going to say bar and then stacked equals true. Okay, and when we do that, we get a bar plot where things are stacked. Okay, and so here we can see kind of the four biggest carriers in the New York area are JetBlue, Delta, Eevee is like ExpressJet or something, and United. Okay, and we can see that United and ExpressJet operate very heavily out of Newark, whereas JetBlue operates most heavily out of JFK, and then Delta has about half of it from JFK and half from Newark, LaGuardia, and things like that. So this is kind of interesting, and that's that. Okay, and you know you have other. Oops, what did I do? If I didn't say stacked is true, then okay, then it doesn't stack them, and it does like side-by-side bar plots. Okay, and you get these tiny little skinny things, but it also just lets you kind of see overall, you know, which ones use the most. Okay. One thing about the unstacked, though, is that the total volume gets lost, right? Like here, Delta is almost as tall as JetBlue and ExpressJet, but because its height is spread across two columns almost evenly, this is a little bit deceiving in that it looks like Delta is a little bit shorter, okay? But all right. So what did I say? Okay. Here I was just looking at flights out of Newark. And I was just, I started, but then I never continued it. I was just curious, like, you know, for Newark, United Airlines and ExpressJet operate the most heavily, and later on I was curious to see if the proportion of delayed flights for these carriers was different for the proportion of delayed flights for the other carriers. I don't know if if the tower's like, oh, we got to keep them. I have no idea. I was just curious, but I ran out of time and I didn't do that. But I was curious if the proportion of UA and EV flights that are delayed is less than some of the smaller carriers. Maybe these big airlines get higher priority. Who knows? Okay, so to be done later. All right. Here I was just curious about flights coming to LA, and then so that we have 4. I think there's only 4 LA airports: LAX, Burbank, Ontario, and Long Beach. Okay, and so and apparently there's no direct flights from New York to Ontario. So these are all just direct flights, right? You can get to New York if you make stops in other places, but they don't show up in the table. The table here are just direct flights from New York to LA. And so we can see, most of them fly into LAX, which is not a surprise to us. Burbank, actually, there's probably 1 flight a day from New York to Burbank. Okay, it's just a little bit over 365. And then here, I don't know, a little bit under 2 flights a day for Long Beach. Okay. And then as far as the carriers that have direct flights, there's, I don't know, these ones. Is VX Virgin? Are they even still around? Airline VX. Virgin Air. And it was an American airline until 2018. Oh, yeah, they just disappeared. Okay, well, sorry. All right, and then I just said, all right, who flies where? And apparently JetBlue is the only one that goes to Burbank. Okay, everybody else goes to LAX. JetBlue also goes to Long Beach. And I think that was part of their advertising campaign, where direct flights from Burbank to New York or whatever, which was okay, I guess that's your thing. JetBlue was appealing to that demographic, and I don't know if that flight still exists or stuff. Okay, but anyway, this was just a little bit more taking a look at our flights data set with pandas. I guess I'll start delving a little bit more into pivot tables and all sorts of the stuff you can do with pandas, which is really helpful. So, okay. All right, have a happy Halloween, and we'll see you guys on Friday.